So today we're looking at permutations. It's a funny word. To permutate means to do something, I don't know, scientific-y sounding to me. But what we do in mathematics is it's taking a certain number of things from a certain number of things. Sound familiar? But yesterday we learnt about factorials. So what a factorial is an exclamation mark, and that exclamation mark means that if we had 6 factorial, it would mean this. And yes, it is stupid to have the times 1 on the end, but that times 1 is important because it is from whatever number we are down to and including 1. 0 factorial equals 1. And that is because this is a multiplicative concept and we don't want anything being destroyed by that 0 factorial, so we use 1 because 1 times anything leaves it the same. If it was an additive model, then 0 factorial would have been 0, because 0 doesn't change something when we're adding things. All right, so it is about the type of thing we're dealing with. So, NPR stands for how many different ways can we take R from N. All right, where the order matters. It matters who got chosen first and who got chosen third. So in our case of seats, if we had 3 seats up here, it mattered that Jess was chosen for the first seat, that Gabby was chosen for the second seat, that Andrea chose the third seat, all right? And then all those combinations within it are part of our answers, all right? So the order actually matters. So you guys are the things in that particular case. The things is how many people are in the classroom, how many different ways can I choose 3 of you? If it matters who came first, second and third, because I was giving the gold medal to the first person, the silver to the second and the bronze to the third. So it does matter which way I choose you. All right, so in that particular circumstance, we want those things to be recorded. And therefore it's going to be a very large set. Because for every 3 people that I choose, I'm going to have what? 6 arrangements, right? And they're going to be part of my permutation set. So this actually has a mathematical formula, and it's n factorial over n minus r factorial, I hope. All right. So what that means is that if we've got, let's have a look at an example. How many ways can you select 3 colours from 8 to make a national flag? Okay, we've decided. So here's our flag, right? We need 3 colours. Now it does matter which one goes here, here and here. We all know that national flags can look very, very similar, but it does actually matter in which order we're choosing them. From our arrangements, we know the answer to be how many choices? How many choices? Right, so we're going to say 3 different colours. So we've got 8 times 7 times 6 as our reason, as our formula. That's from arrangements, and that's fine. We can use arrangements. In this particular case, it's not that bad. All right, but if we're using the formula to find this out, it would be 8p3 equals 8 factorial divided by 8 minus 3 factorial, which is 5 factorial. Now you can put this in your calculator straight away, and in fact there is a button, same place you found the other one. So under that options, probability, next to the factorial, you will see a P button. All right, and again, you just put it in 8 P button 5, and it will give you the answer. But it's really easy to do in your head as well, because from 5 factorial down, it cancels out, right? So after this, it's cancelled it out. So the 5 factorial, this goes 8 all the way down to 1, this goes 5 all the way down to 1, cross it all out, and we're left back with what we've got. All right, so what is the answer? $336. Happy with that? Okay. So, what if we've got 5 friends going to the movies? All right. So we pick 5 friends going to the movies. How many different ways can they sit? Good. He is. All right. So it matters who's sitting next to who, doesn't it? All right. So the order in which they sit does matter. So we've got 5p5, which is 5 factorial over 0 factorial. So there's that 0 factorial in play. All right. We need it to be 1. So 5 factorial, 5 for the first chair, 4 for the second, and we know that the answer to that is 120. But what if Gabby and Kiefer must sit next to each other? Because they want to talk all the way through the movie. Right, so what happens now? How are we going to deal with this? Good. We're going to treat them as one. What does that give us then? Aha. 4p4 it gives us, right? So 4p4 gives us 24 ways. But it might matter who's sitting next to them on the other side, and they might want to switch over. So we have their combination in there as well. So we're going to multiply that by the number of ways that Gabby and Kiefer can sit down. In this particular case, 2 factorial is 2, so it's going to be 48 ways. So they can sit on the left and right, or on the right and left, whichever way round. Sometimes, I'll go over here this time. Sometimes though, we don't. That presents another whole line of things. So if we were trying to make words I put words in brackets because they're not really words, out of Jess's name, how many words could we make? Well, we've got 4 letters and 4 words, so we can go 4 choose 4. So 24 different words, but some of them are going to be the same because we've got 2 S's. So we're going to divide by not 2 but 2 factorial. Okay, so you have to strongly think about what the problem actually is.